Okay, hi guys. Happy Thursday. Hi Aaron. Yes, I'm feeling better. Okay, sorry about last week, guys. I was too sick to have class. Okay, but hey, I'm still alive. And I think I owe you guys a video, isn't it? I think I owe you guys a video, isn't it? Okay, so actually I'm going to jump into a new chapter today. But before we do that, as promised, the video that you have been waiting. Hang on, guys. Let me share this real quick. Okay, guys, can you see my screen? Can you see my screen? Okay, are you ready? Are you ready? I'm not sure if the volume is all right. Let me check. Okay, should be okay. Guys, I'll put the cam off. Okay. I'll off my cam and you will watch this and I'll explain the video later. Okay, so here you go. Enjoy.
It's overloaded.
Radiation is frightening. At least certain types of it are. I mean, my Geiger counter doesn't go off near my mobile phone or the Wi-Fi router or my microwave. That's because a Geiger counter only measures ionizing radiation. That is, radiation with enough energy to rip electrons off atoms. And it's measured in units called sieverts. If you're exposed to more than 2 sieverts all at once, you'll probably die shortly after that. But we're exposed to low levels of ionizing radiation all the time. Bananas, for example, are rich in potassium, and some of that potassium is naturally radioactive. So when you eat a banana, you're actually exposed to about 0.1 microsieverts of radiation. That's 1/10,000,000th of a sievert. Let's use a banana for scale of radiation doses. You know, since people eat bananas, we become radioactive too. So you're actually exposed to more radiation if you sleep next to someone than if you sleep alone. But I wouldn't worry about that, because that dose is insignificant compared to the natural background radiation of Earth. I mean, there's ionizing radiation coming out of the soil and the rocks and the air and even from space. The level of radiation here in Sydney is about 0.15 microsieverts per hour. And that's about average globally. The level's usually between 0.1 and 0.2 microsieverts per hour. But there are places with significantly higher levels. So who on Earth do you think receives the maximum dose of ionizing radiation? Let's answer that question by going to the most radioactive places on Earth. Some places you'd expect to have high levels of radiation might surprise you. I'm in Hiroshima, and that is the Peace Dome. It was about 600 meters above that dome where the world's first nuclear bomb was detonated over a city. It was detonated there to have maximum destructive impact. With a level of radiation today, almost 70 years later, is only 0.3 microsieverts per hour.
I'm about to get into an elevator. We're going down the mine shaft. This is an old uranium mine.
This is the mine where uranium was discovered. It's also the place where Marie Curie obtained her raw material.
1.7 microsieverts per hour. It's about 10 times the natural background that you would have.
Nowadays, most of the uranium has been removed. But in this wall, there's still a small piece, and you can see under UV light, it fluoresces.
Look at that. Fluorescent uranium ore.
This is the lab of Marie Curie. She won 2 Nobel Prizes, one in physics and one in chemistry. And she conducted a lot of her work here. And this is her office. she would have sat right there. Apparently there are only a few parts of this area which are still radioactive. One is this doorknob.
Well, it climbs not much,
But that's like 10 times the background.
yes, more than 10.
And another is the back of her chair. You can still detect alpha particles coming off this spot right here. Apparently after she was working in the lab, she would come, open the door, leaving traces of radium here, and then go and pull out her chair. Welcome to New Mexico. This is the Trinity bomb test site where the world's first nuclear bomb was set off. Right here, right in this spot. This whole area was vaporized. In fact, there was so much heat liberated by that bomb that it fused all of the desert sand into this green glass. And you can still find it here. They've actually named this mineral after the test. It's called trinitite. Yeah, this is the only place on Earth that this has ever been made. The level of radiation here is about 0.8 microsieverts an hour. The trinitite itself is a little bit more radioactive. I've got readings of 2 or 3 microsieverts an hour off them. Now, which place has higher levels of radiation than anywhere we've seen so far? The answer is an airplane. You know, as you gain altitude, there's less atmosphere above you to shield you from cosmic rays. So the level of radiation inside the plane can go up to 0.5 microsieverts per hour at 18,000 feet, up to 1 microsievert per hour at 23,000 feet, over 2 microsieverts per hour at 33,000 feet, and over 3 microsieverts per hour at even higher altitudes and towards the poles. That is Chernobyl nuclear reactor number 4. It melted down on April 26, 1986. So what happened was so much heat was generated inside that reactor that it basically blew the top off, spreading radioactive isotopes throughout this whole surrounding area and over into Europe. And that is why we can still detect the contamination here today. Now right now it's reading around 5 microsieverts an hour. If I stayed here for 1 hour, my body would receive a similar dose to what you'd receive when you get a dental x-ray. So this is not a huge amount of radiation. And one of the reasons why the radiation level is not too high is because they actually removed a couple meters worth of topsoil from this whole area. Then they dumped it somewhere. That's why we can stand here. We're driving into the Fukushima exclusion zone now. I'm just watching as the levels on my Geiger counter go up as we approach the zone. See those black bags at the side of the road? The Japanese are doing now exactly what the people in Chernobyl did, collecting up meters and meters of topsoil. The mask is probably overkill. It's just to stop radioactive dust from getting into my lungs. This is definitely one of the most radioactive places where I've been. Even though the release of radioactive material was less than Chernobyl, only about 10%. Because it's much fresher, only 3 years since the accident, much less of it has decayed. So I've been getting readings up around 5 to 10 microsieverts an hour. And I think we won't be staying here for too long because of that. I'm about to go into the hospital at Pripyat. And this is where the firemen were taken after they fought the fires at the Chernobyl reactor. And in the basement of this building, they have left all of the firemen's clothing. Once they realized it was so contaminated, they chucked it down there.
That here? 80.
But you can see there's a huge pile of that gear there.
Right outside the door, I'm getting 500 microsieverts an hour just outside the door. 1,500 microsieverts an hour. You know, if we stayed here for a couple hours, we'd receive our annual dose of background radiation.
That basement was the most radioactive place I visited, and it's one of the most radioactive places on Earth. If I'd stayed down there for 1 hour, I would have received 2,000 microsieverts. That's a year's worth of natural background radiation. Every yellow pixel here represents a banana. Now that might seem like a lot, but consider that in a CT scan, the patient receives about 7,000 microsieverts. That's 3 years worth of natural background radiation. It's been estimated that the people living around Fukushima will receive an additional 10,000 microsieverts over their lifetime due to the nuclear power disaster. For comparison, US radiation workers are limited to a maximum of 50,000 microsieverts per year. But that's less than another occupation, astronaut. An astronaut on the space station for 6 months will receive about 80,000 microsieverts worth of radiation. But not even they are exposed to the highest levels of ionizing radiation. So can you guess who is? The answer is a smoker's lungs. A smoker's lungs on average receive 160,000 microsieverts worth of radiation every year. That's due to the radioactive polonium and radioactive lead in the tobacco that they're smoking. So not only are they exposed to carcinogens and toxins, they also receive very high levels of radiation. So it's not the people of Fukushima or Chernobyl or radiation workers or even astronauts who receive the highest doses of ionizing radiation. That honor goes to your ordinary, average smoker.
Okay. Hi guys, welcome back. Those who are late, you missed out quite a lot. Okay, so anything you want to say? Anything you want to ask? It's kind of a mind-blowing video, isn't it? How about pilot? Yeah, they said it, but oh, did they? Yeah, I would say it's less than astronaut lah. I would say it's less than astronaut. But if you compare as guys, what he mentioned about the smoker is for a year. That is just 1 year. So imagine all those years of smoking. So you see why I say you don't worry about Wi-Fi, you don't worry about microwave, you don't worry about your phone, because those are non-ionizing radiation. You will not get, you know, anything bad there. All right, so that's the Geiger counter. That's the clicking sound I tell you about. Okay, Geiger counter gives you that clicking sound. Okay, it tells you how strong the background radiation is. Okay, cool story, huh? Cool story, huh? He actually, guys, take a moment to appreciate the effort. Okay, I do have to shout out this channel. It's called Veritasium. Okay, he has millions of subscribers. Okay, deservedly so. He seldom puts out videos, but when he does, you bet it's a quality one. All right, and do take a moment to appreciate that he actually took the time to visit all these places to make a point, right? To show you the radiation. Okay, he went to Chernobyl, he went to Pripyat, he went to Fukushima and Hiroshima and New Mexico, and at the mine in Czech Republic, Marie Curie's lab. Okay, so guys, I hope that 3 weeks, that 3 weeks of me telling you about radiation, yeah, in the beginning was really boring, but I hope those things that I want you to learn first before watching this video, I hope it's worth it. Because if I were to let you watch this straight, you wouldn't understand a single thing. Right? I did talk about sieverts, isn't it? I did talk about what is alpha, beta, and gamma. I did talk about what is radioactive radiation, what is ionizing radiation. So I hope it paints you a picture of what this video is trying to tell. Okay, guys, were you watching? Were you watching? So, any verdict? Any verdict? So you can convince your whoever to stop smoking. Right? Right? And some people can smoke for years without getting cancer. It shows how strong our cells really are. Okay, anyway, so guys, we were supposed to watch this video last week. Okay, I'm sorry, I was down with COVID. I really wanted to have class last week, but unfortunately I couldn't. Okay, so guys, I know it's a bit it's a bit of a rush, but have you received your chapter 9 notes? Shall we jump to chapter 9 today? Oh, you haven't? Oh, haven't ah. Most of my students also don't have the notes yet. I also don't know why. Because physically, I also haven't received mine. So most of my students also don't have the notes. So if you don't, you just have to. Oh, really? Then you have to check with your branch. I think you have to check with your branch. Okay, check with the admin. Or did you submitted the form wrongly? I don't know. Could be any of the reason. Okay, so guys. Oh, you have? Okay, that's good. Okay, so guys, today we are talking about the sun. Okay, and oh, before I begin, we have half a chapter remaining. What do I mean? We have chapter 9 and 10. Only half of this chapter 9 is important. And chapter 10, you can basically ignore that shit. I'm still gonna talk about it, okay? It's like more like a chit-chat chapter, okay? Because I will tell you general knowledge stuff, right? You want a chapter that you study without exam just for fun, you get it. Okay, that's the chapter, right? So this chapter is like half important, half not important. So we'll talk about the sun. Okay, guys, shall we begin? This is also something to do with nuclear. All right, so let's talk about the sun. Okay, before I begin, let me ask you a question. What is the state of matter of the sun? Is our sun a solid, a liquid, or a gas? Okay. Guys, it's a trick question. It's not all of it. Ooh, Satish, how do you know? Yes, the sun is a plasma. Wow, impressive, Satish. You want to share? How do you know this? Okay, so guys, plasma is basically fire. Fire is plasma. Have you ever wondered what fire is? Fire is not a gas. Fire is a plasma. Okay, basically plasma is charged gas, right? This is like advanced chemistry. This is the fourth state of matter. Now, guys, do you know we have 5 states of matter? And the 5th one is Newtonian fluid. Do not ask me to explain what is that because it brings me back so much nightmare from my engineering days. Okay, it's like Vietnam War flashback. I don't want to talk about it. Okay, you can go Google yourself. Okay, guys, basically the sun is a plasma. Okay, and guys, I have a second question. How does a sun generate energy? Where does it get energy from? Does it get it by burning? Is a sun burning? I mean, it's a ball of fire. Is the sun burning? Is our sun burning? Is this combustion? Does our sun burn? Yes, no? Yes, no? Wow, Satish, how do you know? You learned this? Satish, you learned this already, is it? Why are you so familiar? Okay, so guys, the sun is not burning. The sun is not burning. Think about it. Burning requires oxygen. There is no oxygen there. Okay, but instead, it is related to the last chapter, the video we watched just now. The sun will do something called nuclear fusion. Ooh, what is that? What is that? Okay, so guys, let me talk about nuclear. Let me jump back to nuclear a little bit. Okay, Nuclear energy basically comes from two places. Okay, you have two ways of getting nuclear energy. Number one, it's nuclear fission. Number two, it's nuclear fusion. Okay, so what is this? What is this? All right, so they are two way different concept to get nuclear energy. Okay, do you remember what is radioactive? Do you remember what is radioactive? Do you understand the meaning of radioactive? Do you still remember? When I say something is radioactive, that means the atom is very unstable. Good. It's very heavy. It's very unstable. So basically, this is fission. Okay, fission means split. So what do? We take something called uranium-235. You know uranium? It's mentioned in the video just now. He went down the shaft. He went down the mine to see uranium, that piece of glowing thing in the wall. That's uranium. All right. So this is the thing about uranium. When you shoot it with a small neutron, basically this thing will split and it releases a huge amount of energy. Okay? Huge amount of energy. Most of the atom bombs, most of the nuclear bombs, they are made by this way, right? The bomb in Trinity, you know, the one just now the video where he went to New Mexico, right? The desert there, the stone there called Trinitite. The Trinity bomb, the bomb in Hiroshima, dropped on Hiroshima, the bomb dropped on Nagasaki, they are all based on nuclear fission. Okay? They are based on nuclear fission. Fission means split. Okay, we take a very heavy atom apart and it releases a lot of energy. Okay, so what about fusion? Guys, what about fusion? What is the meaning of fusion? Fission is to take something apart. Fusion is the other way around, right? So just now fission is I take something heavy, I split it. Fusion is the other way around. I take two really light atom. In this case, it's hydrogen, because nothing is lighter than hydrogen. I take two nitrogen, I fuse them together, it becomes a helium. Guys, this not only releases huge amount of energy, fusion releases more energy than fission. Fusion is a much scary nuclear than fission. Okay, so if you think nuclear bomb, if you think fission is scary, fusion will put it to shame. Right? Right? I know what some of you are thinking. So why don't we make this? Why don't we make a fusion bomb? And funny you should ask that, because we actually did. It's called hydrogen bombs. Yes, it's called hydrogen bombs. Okay, basically hydrogen bombs, they are fusion bombs. Okay, fusion bombs. If you think fission is scary, fusion will put it to shame, right? So basically hydrogen bombs. Okay, right, guys, the biggest hydrogen bomb human has ever made is the Tsar bomb. Okay, remember I told you about the Russians? Remember I told you about the Soviets? They were trying to one up against the US. So they make their own fair share of bombs. And one of it is the Tsar bomb. Guys, you look at this and you'll find this is really funny. You know why? Because it puts the Hiroshima bomb to shame. See that tiny cloud? See that circle, tiny cloud? That's Hiroshima. And you see the big ass cloud? That's basically the Tsar bomb. Okay? You should be glad this was not put into use. We were close to it. We were close. Right? During the Has anyone heard of the Cuban Missile Crisis? Has anyone heard of the Cuban Missile Crisis? We were this close. We were this close away from total nuclear annihilation. So praise the Lord, you're still here. Right? So, yeah. So that's fusion. Okay, so fusion. So guys, think about this. Think about this. The sun gets its energy from fusion. This is why the sun is basically a nuclear reactor. Okay, the sun is basically a nuclear reactor. Okay, guys, I have a question here. You know all those nuclear power plants? You know just now the Fukushima, the nuclear power plant, the Chernobyl nuclear power plant. All the power plant on Earth currently are we using fission or fusion? Are we using fusion or fission right now? What do you think? That's right. We are using fission. We are currently using fission. You might say, sir, since fusion is better, right? Why don't we use fusion? This is the million-dollar question. Okay, guys, fusion, yes, it creates a lot of energy, but it's too expensive to use. Okay, but according to many scientists, guys, listen, according to many scientists, fusion is the key to solving global warming. It's the key to solve carbon emission. You remember I said this? 80% of our energy comes from fossil fuel, comes from petrol, comes from coal, and comes from natural gas. If we can find a way, if we can somehow find a way to do fusion, we wouldn't need to rely on any fuel anymore. Energy would be so cheap and so huge, we basically solve pollution. So why don't we do it right? Why don't we do it right? Because here's the catch. Basically, to use fusion power, you are creating a mini sun on Earth. Think about it. You are making a sun on Earth. Let that sink in. Okay, what's so hard, isn't it? It's just making a sun. You're creating another sun, right? And you might say, sir, how hot is the sun? Not much. The sun's core, where all the energy comes from, is only 15 million degrees Celsius. It's not much. So think about it. Okay, so have we successfully used fusion? Have we ever made a fusion reactor before? Yes, we did. It only lasts for seconds. Okay, it only lasts for seconds because you need so much pressure and heat. And just this few seconds, it already costs us a few $1 billion. Yes, you heard it right, it's billion. Right? So this is our ultimate goal, is to create fusion power. Right? Yeah, basically, this is a fusion reactor. Basically, you're creating a sun on Earth. And funny enough, the sun kind of looks like a donut. You're creating a donut-shaped sun on Earth to make fusion power. Is it possible? Yes. When is it possible? When will this be cheap enough to be used by everyone? God knows. Could be 2 years, could be 20 years, could be 200 years. Will we die because of global warming, or will we? It's like a race against time, race against the clock. Will global warming get to us first, or we get to solve it with fusion power first? Nobody knows. You see how science is interesting, guys? You see, science is about solving problems. You see why am I so passionate about science? Because we are trying to solve this problem by having something so crazy. Because global warming is such a huge problem. Okay, great problem requires great solution. So this is one of it, right? Some scientists call it impossible, But some scientists, they firmly believe in fusion power. They say fusion power is the key. Okay, because fission creates so much waste, fusion basically creates nothing. Guys, what happens when you fuse two hydrogen together? You basically create helium. Helium is the gas you put in your balloon. You know the balloon, the helium balloon gas? You know helium? The balloon that floats, the balloon that when you inhale, you kind of talk like a chipmunk. That's helium. That's the only waste you are creating if you are using fusion power. Crazy, isn't it? Crazy, isn't it? So this is where we need technology to catch up. When will it be? I don't know. Okay, guys, am I making sense? Am I boring you out? Guys, am I boring you out? Am I geeking out? Because this is my stuff, right? I basically, this is the story I tell my wife when I put her to sleep. Okay, you think I'll be so lame to talk about Disney shit? No, I talked about fusion. Okay, right. So anyway, I hope you guys understand. Your time will start, and that's good. Okay. Those silent majority, are you okay? You guys are with me, right? You guys are with me, right? Okay. I hope me geeking out is not boring you out. Okay. At this point, it's like I'm talking about Star Wars, right? Like I'm talking about the birth of Darth Vader or something, and then you're like, okay, I should care about this. Why exactly? Maybe, I don't know. Okay, so maybe this is a cup of tea. Maybe this isn't, I don't know. Right, anyway, so let's talk about the sun, shall we? Let's talk about the sun. Okay, so basically, the sun uses hydrogen as the fuel. Okay, and when it does fusion, it will create helium. Helium is basically the exhaust, the waste. Okay, so the sun will throw helium away. I have another question. Do you remember the birth and the death of a star last year? What happens when our sun runs out of hydrogen one day? Let's say one day in the future, the sun runs out of hydrogen. There's no more hydrogen. What happens? Yeah, that's good, okay? It will lose gravity, it will explode, and it will turn into not a red dwarf, it will turn into a white dwarf. Okay? And if the star, guys, do you know the sun is a star, right? If the star is big enough, it turns into a neutron star, or it turns into a black hole. Remember that? Remember that? Do you know what is a neutron star? Do you know what is a neutron star? Basically, they say Thor's hammer, Mjolnir, is made from neutron star. Okay, any of you watch Infinity War? Any of you watch Infinity War? Basically, when Thor went to, who's the guy's name? He wanted to make another weapon. He wanted to make the Stormbreaker. Basically, he asked him to hold the gate open so that he can harvest energy from the star to create the Stormbreaker. Remember that? You guys remember that? Right? Because basically his weapon comes from the energy of a star. Okay, if you pay attention to it. Okay, yes, Cyril, hello. Oh, you missed our best part. You missed our video. Okay, anyway, so let's talk about our sun. Okay, let's jump straight to the point. The sun has two layers. Namely, the inner layer and the outer layer. Okay, lapisan dalam, lapisan luar. And each layer has three layers. So the sun has layers. Just like an onion. Remember Shrek? Okay, so basically the sun has layers. Six of it to be exact. Okay, three in the inner and three at the outer. Okay, basically, if you ask, sir, why the sun has has inner and outer? Basically, it's like Earth lah. Okay, our Earth has inner and outer layer too. Okay, inner layer is the one you're standing on right now. Outer layer is this layer of gas around it. Guys, what is the gas around Earth called? What is the gas around you called? What is the gas around you called? The Earth is flat. Okay, yes, it's atmosphere. Okay, so basically, this outer layer is the atmosphere of the sun. Okay, it's the atmosphere of the sun. All right. I mean, the sun has no. Guys, do you know how big the sun is? You know the sun is big, right? I'll talk about that later. Okay, you know the sun is big, right? Okay, guys, just for comparison, Earth versus the sun, and you will see our Earth is funnily small. Okay, yes, it's hella big. Okay, it's hella big. Okay, you see our itty bitty tiny Earth right there. And if you compare to the sun, it's a freaking joke. Okay, and put it into another perspective, guys, do you know our sun is really small among the stars? Okay, if you compare our sun to other stars, you see how funny it is. Our sun is barely a dot. Wait, shit, where is it? There. You see? Our sun is a dot. Okay, and then the biggest star that we have discovered so far is called the Antares. It's you see the comparison? It's comical, right? So yeah. Okay, so if does this give you a new idea of your mama joke? Your mama is so fat, she's basically Antares. Okay. Ton 618. Well, is it something bigger? Okay. All right. So go roast your friend with this. Okay, anyway, so basically we are really small. We are really, really small. Oh, it's the largest black hole. I see. Okay. So that means previously it was a star lah. Okay, anyway, so let's talk about the zone, shall we? Okay, let's learn this one by one. Guys, this is my point for today. You learn this, then we are done. Okay, so let's talk about the core first. Okay, as you know, core is where all the nuclear fusion happens. It's called a core for a reason. Okay, the core is the most important part of the sun. Right, it gives out all the energy. So fusion happens here, and it's the hottest place. Okay, 15 million degrees Celsius. Right, this number is so big that it makes no sense, right? I mean, at this point, it's like a child's, it's like a child came out with it, right? 15 million degrees. Okay, next you have the radiation zone because the heat will radiate out. Guys, do you know the three methods of heat transfer? Do you remember what is radiation, what is convection, and what is conduction? You learned this last year. Melanie, go face the wall. Okay, so basically this is radiation. Okay, radiation. Aaron, go face the wall. Okay, so guys, I have a trivial question. For the heat to go from the core to the radiation zone, you guess how long it takes? That means to travel through the whole radiation zone, guess how long it takes? That fast? That fast? Guys, it's the other way around. To travel through the radiation zone, it takes approximately 1,000,000 years. You see, you don't even know what is it anymore, isn't it? Guys, how long is 1,000,000 years? If you were to take a time machine and go back 1,000,000 years, monkeys didn't even exist. Monkeys haven't even exist, right? As in, maybe you still see dinosaurs around. Maybe you still don't see the oldest Paleolithic human. Okay, you know, when we still go Uga Buga, we still use stone to whack stuff. That's 200,000 years ago. Make sure you don't fist bump T-Rex, you're gonna hurt his feelings. Right. Anyway, so that's your radiation zone. That's your radiation zone. Okay. And then the next zone, we call it the convection zone. Why convection? Because the heat just kind of spins around here. Okay, it goes right here, right round. Spinning around. That's your convection zone. Okay, so guys, that's what you need to memorize it. Okay, so core, radiation zone, convection zone. Okay, teras, zone sinaran, zone perolakan. Okay, this one in BM is called perolakan. Okay, guys, we learned this exact word in Form 2. Okay, great, you don't remember. Okay, so convection zone, so you have your core, your radiation zone, and convection zone. Okay, that's all you need to know. Right, moving on. Okay, let's go to the outer layer. Okay, we start from photosphere. This is the layer that you can see, the only layer that you can see, right? And this, oh, guys, can you see the temperature gets colder as we come out? It starts with 50 million. It goes down to 5 million. It goes down to 2. Okay, and then when it reaches the photosphere, this thing is like really cool because it's 6,000. I mean, 6,000 is still pretty damn hot lah. Our Earth's core is 6,000, right? But it's only the sun's surface, right? So photosphere is 6,000. Do you know what's the meaning of photo? Do you know what's the meaning of photo? Guys, what is photo? Yes, it's light. Photo is light. So all sunlight comes from this layer. Okay? And please, for the love of God, do not stare at the sun with your eyes unless you wish to go blind. Okay, this goes without saying, isn't it? Okay, so that's a photosphere. Next, chromosphere. Okay, this is a white color layer. And can you see it's funny enough, it starts to get hotter again. As it comes out, it gets colder. And when as it goes out, it gets hotter again. You see, this makes no sense. Okay, this chromosphere, guys, this chromosphere, you only see it during solar eclipse. Do you know what is solar eclipse? Have you seen one before? You see the white color thing around it? That's the chromosphere. Right? So usually you don't see this. Okay. On normal days, you can't see the chromosphere. Okay, during solar eclipses, you can. Guys, just because the solar eclipse it looks kind of dark, doesn't mean you can stare at it with your own eyes. I mean, that's another way to go blind too. Right? Please use the appropriate equipment, be it a camera, okay, not just any camera, a special camera. You can use a bucket of water, or you can use a telescope if you're rich enough. Okay, so basically this is a solar eclipse. So you can only see the chromosphere during a solar eclipse. And funny enough, the outermost layer is called corona. I'm pretty sure all of you heard of this word before. Okay, guys, in all seriousness, what's the meaning of corona? What's the meaning of corona? Alcohol brand. Dylan, how would you know? Dylan, you're too young to know this. God damn it. The Kingdom of Tango. Is it? Is it? The Kingdom of Tango is called Corona? You sure or not? I go watch Tango leh. Okay, so anyway, guys, Corona is crown. Yes, you're correct. Okay, Corona is crown. Why? Because this layer kind of looks like a crown outside. Yes? No? Kind of looks like a crown. Because crown you put at the top, so it's at the top layer, so crown. Lo. Okay, so why is it called coronavirus? Because it's a virus that looks like a crown. Okay, hey guys, please, for the love of God, coronavirus is a family. You don't say you get coronavirus. Okay, you saying you get coronavirus is like saying, oh, what are you eating? Oh, I'm eating food. Wow, geez, no shit, Sherlock. Right? So coronavirus is a freaking family, right? So that COVID that I got last week, okay, for the third time anyway. So it's like one of it. Okay. They are like a huge family with many, many cousins and all. Look at this. Look at this. Look at this extended family. Okay. You tell me you got coronavirus. Which one? Okay. It's like I'm in a library. Oh, cool. What are you reading? I'm reading a book. Wow, geez, thanks. Which one? Which one? You see? You have the tiger one, you have the dog one, you have the bat one. You have the civet one, the badger one. Which one? Hedgehog also got. Which one? So you identify yourself as a duck lah. Okay? Some hacker, yeah, exactly. So stop saying it's coronavirus, okay? It's called, you know what is it called originally? This thing is originally called the Wuhan virus. Okay, I like to call it that, okay, because it's easy to call, right? And then when people start calling it Wuhan virus, those butthurt people over in China, they say, oh, you can't call us that. It's very discriminative. It hurts our pretty feelings. Okay, fine, then call it COVID. Okay, because it hurts their feeling. You see, China people are they very sensitive one. Okay, this one hurt their feeling, that one hurt their feeling. So okay, we don't call it Wuhan, we don't call it Wuhan virus, we call it COVID. They caused the bloody virus. They caused the freaking pandemic. So what's wrong calling it Wuhan virus now? Isn't it? But hurt people. Okay. Anyway, so this is the corona. And this is the hottest layer in the outer layer. It's 2 million degrees Celsius. Okay. So these 6 layers are what you need to know for today. Okay, guys. Basically, you get these 6 layers down, you are basically done. This chapter is I mean, next week I'll continue on this lah. Guys, do you know the sun has weather? Okay, the sun has weather. Yes, you heard that right. Earth has weather too. Or sun cannot have weather, man. Okay, yes, the sun has weather. And guys, compared to Earth, the sun is a really crazy planet. It's a really crazy space body. The sun is basically like a crazy girlfriend. Okay? And the earth is like that pitiful boyfriend who keeps getting shit from the girlfriend. What do I mean? You see, the sun, like, the sun is really hot, but it's very temperamental. Same applies to girls, right? So, I mean, guys, I don't know whether you know this. The hotter a girl is, the crazier she is. It's called a hot crazy scale. Look it up, okay? So next time, guys, if you say, oh, I really want that hot chick as my girlfriend, wow, you sure or not? Okay, she will stab you while you're sleeping. Okay, she will try to kill you with a brick. Okay, anyway, so the sun is really crazy. Okay, so the sun constantly explodes. Okay, basically the sun throws tantrum, right? And while the sun is throwing tantrum, it releases a lot of radiation, and Earth is basically fighting for mercy. Okay, the Earth is at the sun's mercy. That's why we have this layer of protection around us. Hopefully, it doesn't hurt us. Isn't this like your crazy girlfriend? She every day, basically, she's having PMS every day, and then she's mad at you for not giving her attention. She'll start throwing household items at you. So what do? You protect yourself. Hopefully, she doesn't kill you. Basically, that's how the relationship goes. Okay? And then, no matter how well you block against the stuff she throws at you, sometimes some stuff does get in. Some radiation does get in. Okay? And this creates a huge disaster. We call it aurora. Right? Okay? Yes, it might look very pretty to you. Sir, aurora is such a pretty thing. How dare you? Yes, aurora is pretty for you as a tourist, right? But for Earth's telecommunication, your Wi-Fi, your data, your GPS is a huge disaster. Basically, it creates all kinds of wireless communication haywire. This is what happens when the sun is throwing a big tantrum. So as the boyfriend, you just pray for your mercy, lor. You're at her mercy. So that's how it goes, right? So guys, lesson of the story, the hotter your girlfriend is, next time, the crazier she is. True story. Okay, ask me how I know. Don't ask me how I know. Okay, that's all I'm saying. Okay, that's all I'm saying. Guys, I don't know whether you agree with this, agree with me or not. A girl is at least a 4 crazy. There's no girl that's less than a 3, less than a 4. Okay, a girl is at least 4 to 10. Okay, if you have a girl that's level 10 crazy, I pray for you. You just hope that she doesn't kill you in your sleep, right? Like the moon. Okay, lor. Okay, lor. guys, personal experience. You will just wake up one day and your girlfriend will tell you, you cheated in my dream. How dare you? And then you'll be there like, what? How is it my fault? Yes, it's exactly your fault. Okay. Anyway, that's all I'm gonna say for today before y'all cancel me. Okay, so guys, 6 layers. That's all you need for today. 6 layers. I know some of y'all don't have the exercise, so I'm not gonna go crazy today. Okay, and I hope my video was entertaining enough. Okay, the video I promised to show you for like 4 freaking weeks, 5 counting last week, right? So yeah, finally saw it. Okay, so guys, I think I'm gonna end my class here. Okay, hopefully next week you have your notes. If not, it's really hard for me to proceed because I really don't want you to write all these down. It's very time wasting. Okay, so before I go, do you have any question? Yeah, you wish, Manny, you wish. Why don't I put a 2-hour one? Then you don't need to go dinner already. Okay, so guys, have a good one. Have a good Thursday. I will see you next week. Okay, so take care. See you. Bye-bye. Bye, guys.